Okay, welcome back. In part 2, we'll explore another oligopoly model that you will have unlikely come across before, the Cournot model. This is a model of an industry structure in which firms compete on the amount of output that they produce, which they both decide upon independently of each other and simultaneously, i.e. at the same time. Recall, oligopolies commonly compete by trying to steal market share from each other. Thus, rather than compete by lowering price, the kink demand curve after all tells us that this tactic doesn't work because everyone else will lower price. Firms instead compete on the other factor that directly affects profit, the quantity of output that they sell. The Cournot model is used when firms produce identical or standardized goods and don't collude. We'll discuss collusion in part 3 of this lecture. The model itself can be expressed using mathematical calculus, which you may come across if you search for the model online. However, while this can be a lot of fun, we will proceed by offering a simple diagrammatic approach. So, the Cournot model. This is named after a French economist, Antoine Augustin Cournot, who lived in the 19th century, and is pictured on the slide. Cournot was inspired by observing competition in a spring water duopoly. Although the model is almost 200 years old, it is still frequently used by industrial economists to analyse oligopolistic markets. The Cournot model is essentially a quantity-based game. The original model assumed there are two firms in the market, i.e. it's a duopoly, which kind of simplifies the analysis. Each firm sells a homogeneous product, in this case water, and each firm will have the same marginal costs of production. In our example, for simplicity, we'll assume these are zero. And finally, each firm will seek to maximise profits. The Cournot story is as follows. One day, a man discovers a mountain spring and thinks this is a great business opportunity, and so he sets up a store selling water to tourists. The water itself is freely flowing out of the spring, and the seller has no other costs since all he does is fill the canteens of passers-by. Initially then, our seller is a monopolist, as there are no other sellers of water on this particular trail. So in this case, the seller acts as if he is a monopolist and he faces the whole demand curve for the market. And he will also have an associated marginal revenue curve as set out in the diagram. Remember that marginal costs are zero, and so these will appear along the horizontal axis. The seller, whom we'll call seller 1, maximises profits in the usual way, and this is where marginal costs equals marginal revenue. And here this means he will produce at Q1A and he will charge a price of P1A. Okay, so later that day, a second stream is discovered along the mountain trail, and a second supplier, whom we'll call seller 2, of spring water decides to enter the market. The question seller 2 faces is this: how much water should they supply, given that there is already another supplier, seller 1, in the market? The answer is, well, that depends. And it depends upon how much seller 2 thinks seller 1 will produce. The essential drivers of the Cournot model involve something called the Cournot conjecture, which implies best guess, and the residual demand curve. The Cournot conjecture essentially refers to each firm calculating its optimal output on the basis that its rival will not change its output from the previous period. The residual demand curve is the amount of demand left over for a firm once the other firm has sold its output. In a Cournot oligopoly, each firm's optimal output will depend upon its rival's output. Each firm will decide independently how much to produce for any given level of production by its rival, by considering the residual demand curve associated with that conjecture. and this in turn will give rise to strategic interdependence between the firms. Each firm needs to take account of these concepts in what becomes a dynamic sequential game. We can explain this process using differential calculus or graphically. We'll use graphs. So back to our original diagram, and recall seller 1 maximises profit when marginal costs equals marginal revenue and produces Q1A units of output at a price of P1A. Note he does not supply the whole market. He leaves some residual demand, as indicated on the diagram. These are consumers who are not prepared to pay P1A and are therefore not served. In theory, these consumers on the residual demand curve are available to seller 2. Seller 2 will look at this residual demand curve, and of course it has its own associated marginal revenue curve, the MR' which is shown on the diagram. Seller 2 also faces zero marginal costs. After all, the water runs from a spring and it's free. And so he will maximise profits when marginal costs equals marginal revenue. And so will produce Q2A units of output. And this is equivalent to the distance between Q1A and Q2A as shown in the diagram. In period 2, seller 1 once again has to decide how much water to sell, but this time he realises that he now faces a rival, which we know as seller 2. Given that seller 1 observed that seller 2 sold at Q2A litres, he bases his expectations of the size of the residual demand curve now facing him on that basis, i.e. he conjectures that the second seller will sell Q2A units of output in period 2 as well. He therefore looks at the market demand curve and leaves the first portion of it, or rather Q2A litres for seller 2, and then operates on the remaining residual demand curve for himself. Maximising profits when marginal costs equal marginal revenue, he produces the distance shown by Q1B units of output. This sequential interactive process continues. Seller 2 sees seller 1 has produced Q1B units of output. Seller 2 then sees a residual demand curve and maximises his own profits, where marginal cost equals marginal revenue, to produce Q2B units as illustrated in the diagram. This process continues over several time periods, until each seller is selling a stable level of output in each period. At this point, each seller is selling an amount of water that is best, i.e. profit maximising, given what his rival is selling. This situation is called a Cournot equilibrium. In Cournot, the output of the first firm is sensitive to the output of the second firm, and vice versa. This is because the output of each firm affects the other firm's perception about the extent of the residual demand curve it faces. We can summarise this strategic independence using so-called reaction functions. These are sometimes called reaction curves or best response functions. A reaction function tells us what one firm's optimal or profit maximising level of output should be for every level of output of its rival. In this diagram, the space indicates seller 1's output possibilities against seller 2's output possibilities. And in this space, we've plotted seller 1's reaction function. So recall from our earlier diagrams that when seller 2 was producing Q2A units of output, the best response for seller 1 was to produce Q1B units of output, and this is indicated in the diagram. We can, of course, also construct a reaction function for seller 2, and this describes seller 2's best response given the output of seller 1. In this diagram, seller 2's reaction function is the red line, and output levels are given along the horizontal axis, and seller 1's reaction function is the green line, with output levels given along the vertical axis. Where they cross, you get the Cournot equilibrium. Okay, so this is the key diagram that you really need to remember if you're considering Cournot, and it shows the adjustment to a Cournot equilibrium. So you can see where seller 1's reaction function, recall that as the green line, crosses the vertical axis, and this is the monopoly output for seller 1, and at this point seller 2 is producing nothing. At point A, on seller 2's reaction function, which is the red line, seller 2 enters the market. In response, seller 1 will now reduce his output slightly to accommodate this and move to point B on his own reaction function. Again, in response, seller 2 will increase his own output to point C. And seller 1 responds by further reducing his own output on his own reaction function to point D. This carries on until we get to point E and the Cournot equilibrium, where the two firms, in our case water sellers, and who are pretty much symmetrical, each produce the same level of output. There is no incentive for either firm to shift from this equilibrium, and so the equilibrium is seen as being stable. With all these assumptions, you may wonder why we don't just assume the right answer straight away and derive the equilibrium outcome. Unfortunately, it doesn't quite work that way, and each oligopolistic market is different. On the other hand, you may think that these assumptions are unrealistic. However, research has shown that decision makers operating in the same market over an extended period of time tend to have similar views of market demand and a good knowledge of one another's cost structure. And in this regard, Cournot provides a conceptual example of how strategic interdependence might work, via perceptions of the players involved around the extent of residual demand. Cournot emphasizes the importance of conjectures concerning responses by rivals to actions as the basis for strategic decision-making in oligopoly, and this is why it is still used in analyzing models of oligopolistic competition today. In addition, we should note that in many markets, competition is based upon output decisions and not price, which is the outcome variable of output changes. You can think of several examples, such as commodity markets, think of gold, oil, and diamonds, and wholesale markets, such as fresh flowers, meat, fish, and vegetables. Prices in these markets are primarily determined by the quantities that firms bring to the market on the day in question. In addition, the sequential quantity adjustment process does seem to happen in some real-world markets. For example, consider the Bath Take the Student Up the Hill bus market. This, of course, is the bus that takes students up from town to campus every day. Initially, there was only one bus company, the first bus company, operating this route. A few years ago, Unibus also entered the market, and first had to accommodate them, and they both now compete for market share. Finally, note that the model is not restricted to two firms. Indeed, industrial economists and game theorists have incorporated Cournot into more complex models of oligopoly. This final slide compares the market outcomes under Cournot oligopoly with perfect competition and monopoly. Under Cournot, each firm earns positive economic supernormal profit. However, the combined profits of these firms is less than the monopoly profits of the market, if the market was occupied by a single firm. This is because output will be higher and prices lower under Cournot. To see this, consider the array of monopoly outputs. Consider seller 1's output when seller 2's output is producing 0. This is given at the point Q1M. Similarly, consider seller 2's output when seller 1 is producing 0. This is given at the point Q2M. Anywhere along the dotted line indicates an industry monopoly output, and here there is potential for the firms to collude and share monopoly profits. More on that in the next part of the session. To compare with perfect competition, well, here you need to assume that one firm satisfies the whole consumer demand curve. Effectively, they would need to operate on the rival firm's reaction function. So in this case, seller 1 would operate at Q1 PC on seller 2's reaction function, and here seller 2 produces 0. Conversely, seller 2 would operate on seller 1's reaction function at Q2 PC, and seller 1 produces 0. The dotted line here indicates potential combinations of output associated with perfect competition. Of course, you only earn normal profits under perfect competition, so in reality, neither firm will choose this course of action. However, you can see that output under Cournot is greater than under monopoly, but less than under perfect competition.